Why do electrons decide periodic table order? Have you ever wondered what makes the periodic table tick? The answer lies in the fascinating world of electrons and their arrangement. Let's break it down in a way that makes sense. The periodic table is arranged based on atomic numbers. This number represents the protons in an atom's nucleus and equals the number of electrons in a neutral atom. Initially, scientists arranged elements by increasing atomic mass, but this led to inconsistencies. The breakthrough came from Henry Moseley in 1913, who demonstrated that atomic number, not mass, is the true organizing principle. Electrons exist in specific energy levels or shells around the nucleus. The arrangement of these electrons follows principles that were uncovered through the development of atomic theory. Niels Bohr introduced the idea of electrons in concentric shells, while Gilbert Lewis and Irving Langmuir refined this concept. They explained how electrons fill these shells in a repeating pattern, which is essential for understanding the periodic table. Elements are grouped in the periodic table based on similar valences electron configurations. Valences electrons are the electrons in the outermost shell, and they play a significant role in determining how an element reacts chemically. For instance, elements in group 1 have one electron in their outer shell, making them highly reactive metals. This pattern of properties arises because, as electrons fill shells and subshells, elements with similar configurations appear again. The structure of the periodic table, with its rows and columns, reflects the rules of quantum mechanics governing electron placement. Each row corresponds to the filling of a particular electron shell. The Pauli exclusion principle and Hund's rule limit the number of electrons per orbital and shell, shaping the table's design. Historically, the periodic table evolved from simple observations of element properties to a model grounded in atomic structure and quantum mechanics. Dmitri Mendeleev created an early version of the table by arranging elements by atomic weight, leaving gaps for undiscovered elements. His predictions were later confirmed as scientists understood the role of electrons in these trends. Understanding that electrons dictate the order of the periodic table allows scientists to predict how elements will behave, discover new elements, and comprehend chemical reactions. This knowledge is vital in fields like materials science and quantum chemistry, where electron configurations guide the creation of new compounds and technologies. In essence, electrons decide the periodic table order because the table is organized by atomic number, which equals the number of electrons. Their arrangement in shells and subshells leads to recurring chemical properties. This connection between electron structure and element order is a key milestone in the history of science, linking atomic theory to the systematic classification of matter.